Okay guys, so this is the last video for this week, the last lesson, and the topic is inequalities. So there are four basic inequalities. You could argue there's others in math, but I'm not going to worry about that. So what we have here first, I'm using x as my variable, obviously. So what we have here is greater than, followed by less than. This one is less than, or equal to. So the presence of half of an equal sign means or equal to. This one is greater than or equal to. So a lot of people just think, oh, the mouth eats whatever's bigger. And when you were a kid and you were just looking at numbers like 5 and 3, you're thinking, oh, the mouth eats the bigger one. But when there's a variable there, the variable could fulfill the inequality or it could not fulfill the inequality. X is greater than 5, for some numbers that's true, like 6, 7, 8, even 5.1. For other numbers that's not true. For like 4, if x is a 4, then that's not true. So you can't just intuitively say that the mouth is eating the bigger one because x is an unknown. So it's good to get used to the actual words. This is x is greater than 5. All right, whatever. So this is an Algebra 1 topic. We're still sort of in that part of Algebra 2 where we're reviewing a lot of Algebra 1 topics. So a lot, if not all of what I do should be something you've seen before, at least most of it. Solving variable inequalities is a lot like solving variable inequations. You want to isolate the variable. That's your goal. So everything we've been doing with solving equations, almost everything applies. However, it is helpful or convenient many times when you do inequalities to make sure the variable is on the left for your final answer. I'll talk about why in a minute. It's not 100% necessary, and if you're really good at this, it may not matter to you. But for a lot of students, when you arrange it so the variable's on the left, it makes other things easier because along with what we're going to do as far as solving inequalities, we're also going to be drawing graphs. So that's a thing. And I'm going to actually come back up here to talk about a little bit more for graphing as well. Now, there is one special situation when it comes to solving inequalities that never applies to equations. It was never an issue at all, and it's right here. If you ever have to multiply or divide by a negative number in solving inequalities, you actually have to take the inequality symbol, whatever it is, and flip it around. So multiplying or dividing by a negative, flip the symbol. So for example, if I have negative 2x is less than 10, or negative 2x, negative 2 times x is less than 10, I don't know why I said that twice. To solve this, because that's times, you would have to divide by negative 2. If everything worked like equations, we'd just go, oh, x is less than negative 5, and be done. But there's a problem with that. Well, the problem is the answers don't work. So if you were to call this your answer, that would mean a number like negative 10, right? Negative 10 is less than negative 5. But if you go to the original inequality, negative 2x is less than 10, and you take that negative 10 and plug it in, negative 2 times negative 10 is less than 10. That gives you 20 is less than 10. Well, is 20 really less than 10? No, it's not. Which means that negative 10 is not an answer. Which means that x must not be less than negative 5. But if you switch the symbol around, x is greater than negative 5. Now pick any number that's greater than negative 5. Well, how about positive 5? Positive 5 is greater than negative 5. Let's go back to the original inequality, the original problem, and plug 5 in. Negative 2 times 5 is less than 10. Negative 2 times 5 is negative 10. Is negative 10 less than 10? Yeah, it is. So that means that this is the right answer. So let me start over. Let me make this totally clear. I do a lot of writing and erasing and explaining and stuff. So here's the rule. If you look at an absolute value inequality that you need to solve, and one of your steps happens to be dividing by a negative number or even multiplying by a negative number, If that ever happens, you must switch the symbol around to get the final right answer. Okay, when it comes to drawing graphs, there's this whole issue of circles or dots. I'm not going to address that now. I'm actually going to get into the examples, and then when it comes time to drawing the graph, that's when I'll address this circle dot issue. As normal, I'm going to do the evens, so your homework will be the odds. As I do the evens, if you feel like you get it, you catch on, and you want to stop the video and get to work, that's fine. You don't have to watch all, well, I was going to say all 20 examples. It's only 10 examples, but you know what I mean. They do obviously get more difficult at the end, so you could fast forward to the end if you want to watch one of the more difficult examples. All right, hopefully I've given you enough space to work here. So here's what I'm going to do. For number 2, I'm going to rewrite the original problem down here so I just have room to work. Okay, what I have is 8n plus 5n on the same side. That means you can combine them together. They're like terms. Then I can, subtract 1. If I want to isolate n now, I can subtract 1 to cancel that out. I get 13n is greater than negative 13. Divide both sides, what am I doing? Divide both sides by 13. 13 divided by 13 cancels out. Negative 13 divided by 13 is negative 1. And now it is isolated. Now before I get to the graph, I'm going to just go down and check my answer so far to see that it works, and there it is. Well, and let's go ahead and look at the graph. Negative 1 from here is right there on the number line, and there's a circle around it. And then the number line itself is shaded to the right. So let's talk about that. If I ask you just to think or conceive conceptually numbers, n, numbers that are greater than negative 1, what are they? Well, 6 is definitely greater than negative 1, so is 5, so is 2, so is 1. 0 is even greater than negative 1. Is negative 1 greater than negative 1? No, it's not. Those two numbers are equal. Negative 1 equals negative 1, but negative 1 is not greater than negative 1. But what about the number that's just one tiny little decimal point in front of that? Is that number greater than negative 1? Yeah, it is. All these decimals, fractions everywhere, all the way up to this line, but not actually including the line itself, are solutions to this inequality. So to represent that, what's done is you circle that negative 1 as sort of the starting point, and what you're saying is that's where it starts, but we don't actually include the number itself. Negative 1 is not greater than negative 1, so we don't put a dot there. We just circle it as the starting point and then shade in the greater than direction. And here's where it comes handy. Oh, my app just crashed. Give me a second. Oh, look. Haskell and his games. Okay. With the variable written on the left, n is greater than negative 1, you can look at this as an arrowhead, and it actually points the direction that you shade on the graph. If the variable was on the other side, that trick doesn't work. Now, you can have the variable on the other side. Negative 1 is less than n is mathematically equivalent to n is greater than negative 1. Back to thinking of this as a mouth. The mouth is eating the n in both answers. That makes them equivalent to each other. So they're essentially the same thing. But when it's written this way, it's a little easier to transfer to the graph. Essentially, you've got this is your starting point, and this is the direction the shading goes. So let's go back up here and address this circle versus dot. So when I say circle, I'm talking about when you have a number line and you've got a starting point, sometimes you circle it, sometimes you actually put a dot on it. If you ever have just greater than, you circle it. If you ever have just less than, you circle it. But for the other two, the two with an or equal to, you do put a dot. Equal to means you include that number. Putting a dot is another way of saying you include that number. Let's see, that's not going to come up till number 6, so hold off on that. We've got number 4 we'll work through, and then we'll see our first problem with a dot. So, okay, negative 2 greater than negative 4x plus 5 minus 7. All
All right, the plus 5 minus 7 are like terms. They're on the same side of the inequality symbol. 5 minus 7 is negative 2. To isolate x, I'm going to want to add 2 to both sides to cancel this out. Negative 2 plus 2 is 0. 0 is greater than negative 4x. This is times, so I have to divide. Now, notice I am dividing by a negative, so we have that special rule that whenever you divide by a negative, you have to flip the symbol around. You get 0 is less than x. Now, this is correct. You could call this your final answer. However, if we rewrite it so the variable is on the left, it looks like this. Notice that I have the mouth eating the x in the original answer. It's still mouth eating the x. But when it's written, let me erase that circle. If I rewrite it this way, drawing the graph becomes a lot easier. So 0 is my starting point. And because there's no equal sign, I just put a circle around 0. The arrow is pointing to the right, so I shade to the right. Now I'm a little concerned because they gave me so much space here. Are they messing with me, or did I get this wrong? Number 4. Nope, that's exactly right. That's exactly how it's supposed to be. So yeah, I psyched myself up. I saw all of this empty space and thought, wow, maybe I was supposed to go that way. Nope. All right. If this isn't sticking, if it isn't gelled yet, just hang with me. I'll, maybe more examples will help. If you totally got this, you remember doing it in Algebra 1, you can just go at your own pace here. Okay, number 6. Negative 7 plus 2a less than or equal to negative 3 plus 4a. Now what we have here is a variable on both sides of the inequality, just like both sides of the equal sign. If it were an equation, we've got to get them together. So I'm going to go ahead and subtract 2a on both sides. Negative 7 is less than negative 3. Positive 4a minus 2a is positive 2a. Now I want to isolate the variable, so I'll go ahead and add 3 to cancel out that negative 3. Negative 7 plus 3 is negative 4, less than or equal to 2a. Finally, divide by 2. I'm dividing by a positive here, so I do not need to flip the sign around. Negative 4 divided by 2 is negative 2. That is the answer. However, I know if I rewrite it like this, it's going to be easier to graph. A is greater than or equal to negative 2. So negative 2 is right here. Instead of circling it, there actually is an equal sign here. That means that the answer can be equal to negative 2. So we put a dot there. That represents the concept of our answer being allowed to equal the number, not just starting or stopping there. This inequality points to the right. The right is the greater than side of the dot, so we shade to the right. And there it is. And you could get fancy. You could use like your iPad's highlighter to do the shading if you want. That looks pretty cool. Let's check number 6 and make sure I didn't mess it all up. Okay, there it is. Dot, arrow in the right direction, and the right answer. All right, number 8. What's special about number 8? Well, it looks like on this one, we're going to have to do some distributing. So let me rewrite the problem here and get to work. Distribute this, I get negative 18a plus 9, oops, not equals, less than 96. Subtract 9 on both sides. Negative 18a is less than 87. Yeah. Divide both sides by negative 18. All right, guys, I have issues. Funny. No, so one issue is you divide by negative, flip the sign. The other issue is, darn, 87 divided by negative 18. Okay, positive divided by negative is a negative. Man, what is 87 divided by 18? I feel like I should be able to do this, but nothing is happening. So I'm going to use a calculator. 87 divided by 18. What? All right, where did Haskell screw up? Did I copy the problem? Oh, I'm such a dum-dum. Hey guys, is 3 times 2 9? No, 3 times 2 is not 9. 3 times 2 is 6, which means I would have had to subtract a 6 here. And so I subtract a 6 there. And what's 96 minus 6? That'd be 90. Now let me go to my calculator. 90 divided by 18 is 5. Yeah, that makes a little bit more sense. So negative 5, rather, because there was a negative sign in there. And my variable is already on the left, so what do I have? Negative 5 is my starting number. There is no equal sign, so I circle it. The arrow, again, is pointing to the right, or the greater than side, so I shade greater than. Has every one of these been the arrow to the right? Well, that's real creative. All right, let's check number 8 just to make sure. Yep, looks good. Okay, I'm just checking. Number 10, I'll go to the left. Ooh, and then we get to some special ones. All right, number 10. Let me see here. 133 is greater than or equal to 3 plus... I'm going to go ahead and distribute this now, save a little time. So 5 times 6 is 30, and 5 times 4 is 20x. And then 3 plus 30, I can add those together. I get 133 is greater than or equal to 33 plus 20x. Isolate x, I'm going to subtract 33. 133 minus 33 is 100. Bring down the 20x. Isolate x, I need to divide by 20. I'm dividing by a positive, so there's no flipping the sign. 100 divided by 20 is 5. 5 is greater than or equal to x. The x is isolated, so we are officially done. But again, if you rewrite the problem with the variable on the left, that's a little bit preferable. This time the mouth is eating the 5, so I need to go like this. X is less than or equal to 5. So 5 is like, sometimes this is called a critical number. It's like your starting point, like I've said before. I'm going to do a dot on 5. Why a dot? Because of the equal sign. And now the arrow is pointing to the left. Left is less than. That's nice. They both begin with L. So left is less than. And there's my picture. And I already checked this before I started, but I feel like I need to put the little check mark there too. So. All right, let's look at number 12. And just so if you're still with me, the problems at the end get into some special cases. We did special cases before. So if you feel like you get this, you still might want to fast forward a bit to the end to see the special cases. I don't know. All right, so let me bring this down. 6 plus 2b less than. Distribute that 4. I get 4b plus 1. I need to get my like terms together, so I'll go ahead and subtract 2b. I get 6 less than, 4 minus 2 is 2, plus 1. Ooh, am I going to get a, nope, I screwed up. All right, do you see my mistake? I caught it at least this time before I went too far. If you see the mistake, tell me in the comments. 4 times 1 is not 1. 4 times 1 is 4. Duh. Okay, we can continue. Minus 4 on both sides. 2 is less than 2b. Divide by 2. Oh, 1 is less than b. Again, that's officially done. It is equivalent to the final answer, which means it's correct, but if you invert it, rewrite it like this, it's just a little better. 1 is our critical number, our starting number. Does it get a point or a dot? I'm sorry, those are the same thing. Does it get a dot or a circle? Okay, the answer is circle. The arrow points to the right. B is greater than. This is the greater than side, so I shade greater than. Point or a dot. What am I thinking? A dot or a circle? No equal sign means a circle. All right, let's check number 12. And yeah, that checks out. Everything looks good. Okay, let's look at this. All real numbers, no solution, no solution, all real numbers, crazy town. Number 14. I'm going to bring the problem down here. Less than or equal. I'm going to go ahead and distribute that. 7k minus, what's 5 times 7? 35 minus 2k. These are like terms, so I can get those together. 5k minus 35 is less than or equal to 5k minus 35. Oh, excuse me. Oh my gosh. If you were wearing headphones, I am so sorry. I turned my head. Hopefully I didn't blast your eardrums. I tried to hold back and I couldn't. Okay, so we have variable on both sides of this equation. Minus 5k, minus 5k. That cancels out. I get negative 35 is less than or equal to negative 35. Okay, so this is special. What on earth could this mean? Well, like before, when the variable completely cancels out of the problem, it means either two things. It means we have an all real number situation, or we have a no solution situation. And what it comes down to is what you see here. Is negative 35 less than or equal to negative 35? Well, the or equal part means that if they are equal to each other, then it's a true statement. So this number can be less than that number, or it can be equal to that number. So negative 35 really does equal negative 35. So this is a true statement, which means this is an all real numbers answer. So you circle all real numbers. That's your answer. Not this, not that. Those aren't the answers. All real numbers is your answer. Or if you recall, there's a symbol, looks like that. And then how do you graph all real numbers? Well, when you shade, the numbers you shade are your answers. So if your answers are all real numbers, you have to shade all numbers, the entire graph. That's as sloppy as I could make it. Here, let's get neater. I'll go ahead and use the highlighter. Shade the entire graph, arrowheads in both directions. There it is. So if the variable cancels out, it's a special case. If you have a true statement, all real numbers. If you have a false statement, no solution. Hold on. Number 14. Check. There it is. And the next one is going to be no solution. I'll check it now. We just know it's going to be no solution. So how do we know it's no solution? Bring this down. Distribute the 3. So plus 3n minus 6. Those are like terms. You can combine those. So you get negative 6 plus 2n is less than 2n minus 6. The 2n on each side, those are like terms, so I can subtract and combine those. 2n minus 2n cancels out, gives me negative 6. Bring down the less than. Those also cancel out, bring down the negative 6. The variables are gone, that means it's special. Is the number negative 6 less than the number negative 6? No, they are the same. This is a false statement, so that means there is no solution. So circle no solution. And then how do you graph no solution? Well, you shade the solution. If there's no solution, there's no shading. So you don't graph anything. And we already checked it. We know that's right. A couple more and we're done. Number 18, 6 plus 8n less than or equal to, distribute negative 8 times negative n is positive 8n, negative 8 times negative 1 is plus 8. I'm going to subtract 8n on each side to get the variables combined. And that cancels out. 6 is less than 8. 6 is less than or equal to 8. Is 6 less than 8? Yes, it is. Does it equal 8? No, but that's okay. As long as one of those things is true, this is a true statement. True automatically means all real numbers. Shade the whole thing. And that should be it. Let's scroll down and check number 18. There it is. And for kicks, number 20, gonna be a no solution. Let's just make sure we know how to do it. So negative 2 minus 2x less than, distribute here, negative 2, distribute negative 2x. If it saves time, instead of going plus 2x, draw a line, cancel out. Most mathematicians, people who get really good at math, they say, oh, if the same thing is on both sides, they just cancel each other out, and you get negative 2 is less than negative 2. Is negative 2 less than negative 2? No, that's a false statement, which means no solution. Circle that. What do you shade for no solution? Oh yeah, you don't shade anything. We already checked it. That's exactly what the answer is supposed to look like, so we're good. All right, so this page here, expect special cases, the same thing as the notes. The rest of it, you just got to try and see what happens and check your work. As always, shoot me an email or make a comment if you have questions or issues. Good luck, and I will talk to you later.